Hi, everyone, and welcome to today's collaboratory seminar series presentation. We have an extremely interesting session planned for today, focused on methods of learning health systems applied to radiation oncology, drawing on the experience of our own department here at Michigan, and I will introduce our speakers in just a moment. I'm Chuck Friedman. I'm one of the two co-chairs of the collaboratory. Doug Van Houweling is the other co-chair, and he will be moderating our question and answer sessions later on today. Just to let you know, this session is being recorded, and the link will be shared with all attendees and registrants. The session's live closed captioned, and we would like this session to be extremely interactive, so please post your questions in the Zoom Q&A pod. You can do this anytime in the session, and you will have the opportunity to unmute to ask your question in real time. Also, we found that participants enjoy using the chat pod, so this is also be available for you to post comments and have virtual conversations. But if at all possible, if you would like to post a Q&A or post a question, I should say, that will be addressed during the session itself, please put that in the Q&A if at all possible. We have a number of truly excellent sessions upcoming for the remainder of the winter term of 2022. On February 24th, we are going to have a session focused on data sharing for learning health systems and clinical research. And we're very fortunate to have Jeff Brown, who has just left Harvard to become the Chief Scientific Officer at Trinetics, along with our own semi-retired Marcy Harris from the School of Nursing, who is very active in setting up some of our resources for network-based research here at Michigan. Turning more to the very important concept of network-based research, in March, we are going to have a presentation focused on one of the PCORI networks in which we participate, the PATH network, based at the University of Pittsburgh, and Kathleen McTighe, who's the director of the PATH network from the University of Pittsburgh, along with Dave Williams, our own Dave Williams, will be presenting about that work. And then in April, we are going to have a presentation that will also be extremely interesting and will focus on AI and machine learning methods in depth. So that's our plan for seminar series presentations for the rest of the winter term. So today, our speakers will be Chuck Mayo and Michelle Mierzwa, both from our Department of Radiation Oncology, and I will introduce them in a bit more detail now. Dr. Mayo is Professor and Director of Radiation Oncology, Informatics, and Analytics in our Department of Radiation Oncology. He has 27 years experience in medical physics and translational research in the areas particularly of advanced treatment planning and the study of normal tissue tolerance. His current interests are in healthcare informatics, application of statistical methods in treatment and outcome modeling, and automation of advanced treatment planning methods, as you will hear in this presentation. And as a former physics teacher myself, I can't resist pointing out that in 2016, he received the honor of Physics Teacher of the Year in Radiation Oncology. So that's something I wanted to be sure to mention. Now, Michelle Mierzwa is an associate professor and associate chair of clinical research and co-chair of head and neck clinical trials here at the University of Michigan. She has 13 years of clinical experience in treatment of head and neck cancer Her research interests have included novel chemoradiation regimens for head and neck cancers, as well as imaging markers and biomarkers of tumor response to radiation and toxicity. And while we are mentioning awards, I will point out that Dr. Mierzwa was twice the recipient of Educator of the Year from the Association of Residents in Radiation Oncology. So thank you both to our speakers. And Chuck, Mayo, I think you were going to be speaking first. And let me turn the screen and the floor over to you.
I think you need to allow me to, it says the video, need to allow me to share my video. Okay. There we go. That works. All right. And I will share my screen. Can you all see the screen?
Yes.
That's a yes. Okay. So thank you very much, Chuck, for inviting us. We are very thrilled to be able to share our experience in radiation oncology as we've been constructing a learning health system. We're also really enthusiastic to see a number of people from other departments who we've interacted with over the years who are doing their own efforts carrying this on. So this is clearly a community effort and various groups doing it. I'll be very interested in learning what other people's experience has been as they've gone through this process. There's a couple of fundamental core principles as we're doing this. I mean, we believe that we should be able to learn from each patient how to better care from the next. That's what our patients want. Everything should get better as we go forward, but it becomes really difficult to be able to do that absent a learning health system where we can use real world data that comes from routine practice. And one of the side benefits we've learned come from doing this is that we also, as we start developing these systems, find opportunities to use the data, to use the technology to introduce automation in performing tasks, automation in carrying out quality and consistency measurements. So I think there are many dividends that are paid in clinical practice by building learning health systems. It's a multi-pronged effort to be able to do this. And so, we have a data pipeline, and there are a number of components that need to be factored into this. And so, for example, if we're starting out with looking at local registries, in our departmental effort, it ultimately feeds into what happens in institutional registries. As we then look at colleagues in other institutions, and we're looking at the potential for multi-institutional registries, most of those efforts really grow out of research. But increasingly, as we deal with researchers from our own and other institutions, we see where this can feed into guiding healthcare policy with better, more comprehensive data. It's a difficulty with many of these sets of data that they really tend not to be artificial intelligence ready. So just having the data in a bucket doesn't make it ready for the applications that are using artificial intelligence to use it. A lot of effort goes into cleaning that data and organizing it so it can make sense. And so we can see how where we are presently with many investigators carrying these efforts manually and understanding how AI can come in with big data to be useful. Ultimately, this should be pointing toward a future where all of this is much more automated and standardized. Again, so we're focusing on the use of the data. And as we look at the scope of data that we have, we've become increasingly aware and actively in taking active steps in thinking about ethical integration. So right now, a great deal happens on a case-by-case basis. But we can see as we're interacting across institutions that really this needs to pave the way to something more unified. There are going to be 5 primary themes that we're going to talk about during the presentation. Some of them will be highlighted in the slides just so you can see them. But the domain expertise, standardization, infrastructure, analytics, and ethics. So by domain expertise, I mean that the construction of these systems really can't be well carried out. It's not just an IT problem, right? It's not just a technology problem. It really requires integrating the clinician's perspective with the technology, understanding how it all goes together with policy so that all of those pieces can come together. It points toward, learning health systems and construction as a sociologic effort to be able to do that within the culture of a department. Within our own department, we are blessed with a leadership team that has seen this potential of data and worked in this direction for decades. So Dr. Ted Lawrence has been leading the department and also outside, working with Astro and ROI in constructing centralized databases, seeing that potential, believing in what it could be, what it could lead to, and those uses. Again, similarly, Lori Pierce has been a leader in Astro as well as our department for doing this. Jim Heyman and Reshma Jagzi. Reshma's early papers, long before I arrived, were pointing out how this data in the long term could be benefiting our clinical practices. So we've had a truly visionary group here at Michigan already who are thinking globally while acting locally, and locally includes here MROC. Standardization really ends up being at the crux of a lot of these efforts. So, imagine a world where you take your laptop and everywhere you go to plug in your laptop and they have a different outlet configuration. It's not quite the same. And so you're going to spend all of your time just seeing how can I get some electricity to drive this platform where I'm going to have my ideas instead of just focusing on it. And lack of standardizations in how information is transmitted, how we organize it, how we express it so we can think about using it. Really, that inconsistency adds a lot of effort and it compromises the potential value that we can have from constructing these systems. The infrastructure takes a lot of effort, and we got started early on with Mark Kessler and Randy Tenakin leading these discussions in how do we make a system that can automate accurate data aggregation. This is really important because we ultimately want to focus on how do we use these resources to learn from it? What can we do that's productive with it? But without a well-developed infrastructure, your focus is really forced toward a lot of effort in gathering and cleaning the data. Analytics is very important, and I find, pointing back to the data culture, there's an interesting challenge between the clinical trials approaches that have been embedded and what's emerging with real-world data gathered from routine practice. From our standpoint, we don't really see it as an either-or approach. We see what you can learn from routine clinical EHR data as constructing a pathway for better formed data-driven hypotheses that then later come into clinical trials, and for forming a pathway to go back and carry out validation studies. So it's not really a tug of war, but how to make that obvious and what that pathway looks like is really a challenge. And this is one that, again, in this leadership from our group, we've seen in MROC and how these questions are being answered. Ethics, we've been very fortunate. So with Kate Spector-Baghdadi and Joden Platt and Reshma with early research and leadership in this area, and helping us to sort out how do we integrate this as we're constructing the system so that we have ethical aggregation and use of the data and the AI algorithms derived from it. This strengthens both trust and quality. And so our efforts to recognize we're underrepresented with respect to races in our data set also shows the problems with the quality of predictions we can make from it. And so by recognizing this and calling it out as a first order thing to be concerned about, it helps us in the long run to both represent our patients better, but also to improve the conclusions that we can draw from it. It also means that it's helping with trust with our patients, because if they can see the connections for how we're using the data to benefit them, and know that we're being good stewards of their data, then the information they're providing to us, they're going to be more willing to. Whereas if it's not obvious that we're making this a first-class concern in how we're using the data, it's going to be harder to have the trust and get the data for the kinds of conclusions you would like to draw. So I'll switch over to Dr. Mierzwa here.
Thanks again for having us. So I will be bringing some clinical perspective to some of the concepts Chuck has been talking about. First, so radiation oncology is a highly data-driven and technology-driven specialty within oncology. We like to have quantitative measures regarding our patient outcomes, tumor outcomes, survival, but also toxicity measurements, which are usually measured on a variety of scales in oncology. I promise there will only be 2 technical slides. Next slide, please. But I wanted to give just a 2-minute overview of how radiation therapy is planned to help understand all the different facets of data we're able to aggregate in our department. So on the left picture, you see an axial, sagittal, and coronal slice of a patient after undergoing a radiation planning session or simulation for head and neck cancer. So after this scan is done, the physician will go into the scan and contour or circle area of tumor, area at risk for tumor, and then you can see mostly on all of these planes that we will contour normal tissues. So in the case of head and neck cancer, saliva glands, the oral cavity, the pharyngeal constrictor muscles, which are related to swallowing difficulties, voice box, spinal cord, brain, mandible, pretty much all of your normal tissues. So those all have a volume and can estimate dose later. So on the picture on the right, you can see we've allocated dose to this plan in an axial slice where the rainbow colors are kind of a topographic map of radiation dose. Next slide, please. And this creates in our planning algorithm a dose volume histogram or DVH curve, where at the bottom of this slide you can see every different structure that we have circled or given a name to, and some of these are a little bit of technical jargon, but you can see left parotid and right parotid, spinal cord, oral cavity, and submandibular gland. This DVH curve will give us an estimate of dose to the volume of the structure, which can be quantified and has been used in many different studies to correlate with toxicity measures, quality of life, and even tumor outcomes. Next slide, please. So this list of head and neck radiation toxicities is really the point I want you to get out of this slide, is just that there are a lot of them. And they may occur at a variety of time points after going through radiation, from weeks to months to years down the road. When we think about how to quantify those in the medical record, they may be found in a variety of different places. So standardization across the medical record would be ideal. We may get some of these from patient-reported outcomes. We may get some of these from labs or physician-graded toxicity. You see tinnitus or hearing loss. Those might be quantified in an audiogram, which is acquired in a completely different department outside of radiation oncology. So standardized methods of collecting this data are really necessary to comprehensively understand the toxicities of radiation. Next slide, please. So getting to the toxicity measurements correlated with dose that I was discussing earlier. So this is a paper based on about 90 patients that came up out of our department in 2011. It was the first actual national or international paper to show that. So on the 2 panels on the left we're looking at the two columns on the left are looking at results from swallow studies, which would be acquired in speech and language pathology, and the two panels on the right are looking at quality of life outcomes, which may be acquired in the radiation oncology clinic. And on the top, the x-axis tells you pharyngeal constrictor dose, so looking at dose to the pharyngeal constrictor muscles and how they correlate with those side effects. And on the bottom is dose to the larynx. So many studies like this have in all of radiation oncology that have made correlations between dose and side effects have been based on 100 small pockets of patients, but the ability to aggregate larger amounts of data throughout our department and throughout a multi-institutional collaboration allow us to, as Chuck said, verify results of randomized trials and to really and to more decidedly look at specific ways to improve the toxicity and outcomes related with radiation. Next slide, please. And this is just, so out of that particular swallowing outcome issue that we were just looking at a slide on, that had been validated in multiple institutions, and there is now randomized data to suggest that if you can keep the dose of radiation to the pharyngeal constrictor muscles below a certain level, that you actually improve swallowing outcomes in the long run for patients. Next slide. I think we're back to you.
Great, thank you. So we began about 6 years ago asking what are we going to need to do to construct a system to be able to improve our ability to use the electronic healthcare data that we have. And in the clinical practice and research tier, you can start to see that there are a number of different systems that are not linked in terms of consistency for how they represent the data, that are all part of treating the patient. And we need a way to be able to aggregate that data into a single system to be able to integrate the concepts, not just the data, but the concepts, so that we know how to tie this back to clinical practice. This points to a lot of effort in the interfaces that are used to be able to construct these systems, and ultimately to how we would like to use this in analytics for visualizing, collaborating with other institutions. As we do this, we're aware it's going to point back, what we learn from analysis is going to change how we do our interfaces and what we decide we need to draw from each of these systems. So it's going to be a continuum as we do this. When we looked at the barriers and the models that are used for how to gather the data, we realized that the common term of data mining actually misses the point. What we're needing to do is build a data culture. And so being able to improve our ability to construct a learning health systems is not just the technology, it's also recognizing, as Ted would say, we need to learn to plant in straight rows. So how are we going to lay out data so that we can start to bring in machinery to be able to use that? So this reduces the variability in the data, it increases the veracity. It points us off to then starting to be able to get a high volume of data that can be gathered very quickly with a good velocity. And there is this loop that we recognize again in this iterative process that has to include value. That as we're doing this and we're motivating people to use these systems and embrace these standardizations, we have to also commit to showing value to them for doing that. The learning health systems we constructed in radiation oncology is the Michigan Radiation Oncology Analytics Resource, MROR. So I'm forever grateful to Mark for this name. This lines up perfectly with what we're doing. We gather data from multiple systems, other institutional databases, our treatment planning systems, record and verify systems, Epic, into an application server that does a great deal of work in cleaning up the data and forming those integrations that then goes to an SQL server that allows us to carry out operations like text searching, machine learning, and analysis and constructing dashboards. We have over 47,000 patients in the database, millions of longitudinal records. And what you should draw from this is that it's really very comprehensive. So it's not just about radiation oncology. We understand patient-reported outcomes, but we also understand charges, diagnosis, toxicities, notes, encounters, medications. So again, appealing to what is it that's in the physician's mind when they're saying, I have a question I need to answer, here's the pieces I need to do, following what they need to know and trying to assemble a system that puts it all in one place so that we can address those questions. As we do this, we're increasingly aware of the ethical challenges for doing this. So not only are we gathering clinical information and demographic information about the patients, increasingly the possibility of adding genomic information comes into this. So as stewards of patient data, we have to think about how we're managing this triangle. We want to make advances, but we need to maintain trust and think about the risks for how where it may go in ways that we didn't anticipate and how it may be modeled in a way that we didn't anticipate. So it makes our responsibilities broader. I'll show some of the quick benefits that we've had from constructing the system, just so you know. Yes, there's the value proposition. So we have an extensive number of dashboards that we are able to construct off of this to find out where our patients are coming from, what kinds of diseases they have, chart longitudinal progress of lab values, understand which patients are treated on which machines and how our utilization of resources is proceeding. This was an interesting case during COVID. So we had questions as the spring rolled around and we started seeing numbers dropping in 2020 of what was the implication for our future for the next few weeks and what might happen. And as we count the number of patients that entered into our system from the number treated per day, and we construct a model based on that information and then make projections based on the number of patients filtering through in our ingress system for simulations to look for what this might portend for our near future. So this was a place where having this system actually gave us some quantitative data to deal with. Another use case is when you're expanding. So we had a site that was looking to add another linear accelerator, which we use for treating patients. And there were questions about the catchment area. So the center opened, and then a year later, where are the patients coming from? And with the system, it becomes very straightforward to start to answer these questions. So it's not just all about research, it's also about clinical practice for what you can gather from those systems. This was the Quantec, quantitative analysis of normal tissue effects in the clinic, was a landmark collaborative professional society sponsored effort, looking at the literature across with many researchers from multiple institutions to try to understand what does the data in the literature tell us are the dose response thresholds where we would be worried about a toxicity. A highlight here that it had leadership from Dr. Avi Eisbrook and Randy Tenakin already in the steering committee for that group. Many of the disease site specialties had a common problem. So we treat hundreds of thousands of patients in the clinic every year. If you're looking across our nation, you start to include other nations. It's a very vast population. But when you then go to the literature and say, okay, we should be learning from data sets for very large data sets for what tolerances are to that radiation, and you start to discover those data sets are kind of small. So this was one of the efforts, one of the subgroups I was a part of, looking at optic nerve damage. And it's interesting, if you look at these yellow highlighted, you're looking at the size of the samples in these publications. 2 patients, 4 patients, 10 patients. It's a long way from what we know exists in our system. So why? What's the barrier for being able to do that? And the underlying reason for a lot of this is just the effort to try to pull in this data. Yes, they're nominally an electronic system, but the electronic system was never actually set up to make it easy for you to pull it back out again. So we have an issue that we need to take on with infrastructure, We also need to turn back to the standardization. So if we're looking at our clinical processes that lead to nomenclature so that all of this can be pulled together, those are pieces that are needed to be able to get these denominators to numbers that are bigger. Here's an example in our own practice where this came up, where we're looking at how we name target volumes. This was in 2015, there were over 2,600 different names for how this was done. It's a really big problem. And it happens for all of these tissues. You know, if I want to look up optic nerve and there's 30 different ways that people write optic nerve, I'm going to have a hard time finding all that data. We work together with researchers from multiple institutions, pulling together a group to standardize this nomenclature. We work through professional societies to be able to do it and put out a publication that's become widely adopted for this standardized nomenclature. This was done with multiple professional societies, so American Society of Therapeutic Radiation Oncology, ESTRO, AMD, Canadian organizations. Canada has subsequently taken this and adopted it in a pan-Canadian standardization effort just across Canada for using that as the basis for work that they're doing. And so these collaborations move outside of our institution and start working with the larger community to be able to construct these standards that can then make it possible to, within your institution, find data better. And then in the long run, as with NRG for clinical trials, be able to make it easier to send that data to centralized systems to be able to analyze common experience. So a dividend for us doing that, and if I start to look at the number of PTV names, and I chart it by year, you know, in 2015, there were over 700. And then again, this points back to our leadership. So with Dr. Lawrence, Dr. Pierce, Dr. Jagsey, Dr. Heyman, all saying this is really important and we support trying to go in this direction with standardization, we start to see this coming down, which means as we can gather the data, now we can make sense of it. I can find the targets that had those different doses because I've got a relatively small number of names instead of a whole lot of different names and trying to guess which one goes with the target. This is another dividend. We're combining nomenclature with our learning health system, MROR, and artificial intelligence. So because you remember in that contact figure I was showing you, we're looking at a relatively small number of patients. Because we had this standardization, we could then go and say, well, let's look at a particular toxicity, dysphagia. And I want to learn from, I'm not going to do a clinical trial, I want to learn from our experience with our routinely treated patients. And in this early one, we were able to get 439 patients we could learn from. And one of the outcomes from this was looking at all the different metrics that could be pointing toward dysphagia from a wide variety of organs, right? We've standardized the organ naming, so now I can find them. We can pull out the dose constraints. So we looked at over 738, and we find the one that makes the most sense here is a dose constraint on 25% of the superior constrictor muscle. And we can see from the data, this is supporting the relevance there. And so this got folded into clinical practice as one of the metrics that we measure. I'll transition over to Dr. Mierzwa.
Before I start talking, I think we had said we were, if we can stop for a minute if anybody has questions.
Yes, this is Doug Van Houweling. We do have two questions. One, the first one from Mary Wise was asking whether or not what the impact of the new imaging system at Michigan Medicine has been to IMROR. How much have you folks had to redo in order to accommodate that change?
Yeah, thanks for that question, and it's a great one. So it exemplifies one of the strategic decisions we took in designing IMROR was that the source of truth should always be the clinical source system. So that meant we designed IMROR so that it's periodically wiped and refreshed. So that meant the technology has to be wicked fast to be able to do that. And so one of the dividends we had is with the new imaging system, we took a look at those implications, but it just meant it was a smooth transition. When that system was modified, we come back to our system and we're absorbing that data from the source of truth as the hospital has determined what it should be. Another advantage of that is anytime people make corrections, we also absorb them. We don't have to do anything special. Does that help?
Okay. And the second question is, does IMWAR include pediatric data as well?
It does.
Very good. Well, I think we should let you go forward, Michelle, and I'm sure we'll get more questions as we proceed.
So in thinking about how to standardize some of the information in our progress notes and consult notes, where the electronic health record gathers a lot of information that is often difficult to search in clinic notes. We have attempted to standardize a lot of our notes in the clinic to be able to find similar data between patients. Next slide. So this is an example within a head and neck cancer note, although this is true of all disease sites, where we're standardly capturing physician-graded toxicity during treatment and after treatment in CTCAE grading, which are all smart lists that are with standardized answers. So toxicity is collected, disease control status is collected, disease site location. Those are some of the basic information that are being collected throughout the clinic. Next slide, please. Chuck had mentioned earlier that we have also been able to create a variety of dashboards, and this particular dashboard that we're looking at is a toxicity dashboard from 2020. So a few thousand toxicity records in this data. On the left, you can see alphabetical toxicities and the number of on the x-axis, the number of toxicity counts we have. That red arrow is pointing to dysphagia, which helps us routinely quantify things for our toxicities in clinic for even patient education. So those different colors represent different grades of toxicity. When you do the math on the small area of turquoise, the rate of needing a feeding tube during head and neck radiation in our department is 8%. Next slide, please. So we've also, in a multidisciplinary fashion, partnered with our colleagues in otolaryngology and medical oncology to integrate and standardize the tumor board notes similarly. So putting disease status, pathology and imaging, patients' past treatment information, and previous record review, if available, into the EHR. So this is entered during tumor board to help us within the repository look at clinical trial candidacy for not only ongoing trials, but areas to develop new trials, can be used for quality improvement and patient outcome databases. We treat within head and neck cancer a variety of rare orphan diseases, which are often hard to aggregate data for reporting experiences. That's facilitated with this system. And as Chuck pointed out in earlier slides, ideally, we were working on integrating this with tumor bank specimen data. So working towards the biology and next-gen sequencing area of things. Next slide, please. And this is an example of some of the fields captured in the tumor board note, including path staging. The thing I highlighted with the red arrow a little bit on the right is disease status within this tumor board. We try to bring every new case and every recurrence to tumor board, which is so the disease status is captured here. And I think that's important because it is really hard to capture recurrences within especially a single departmental database. Patients are often going to seek other treatments in other departments, and clinical trial candidacy is also recorded here. Next slide, please. We have thought a lot about the use of PROs, patient-reported outcome questionnaires in our department, so lots of reasons to think about it. There are several publications that suggest it may streamline consultations, you can monitor patients' quality of life over time, and help facilitate survivorship and addressing toxicities of treatment. Patients may be more willing to discuss difficult topics if kind of through a questionnaire. Next slide, please. And this survey from 2014 suggested that most physicians felt it enhanced their practice and communication if kept small, is the question. So we've given a lot of thought in our department into balancing patient fatigue and answering many questions. Many oncology surveys are 30 to 65 questions about how you're feeling at each and every visit. May take and as well as we've thought a lot about the number of fields for physicians to look at as well, and fatigue versus, so time invested versus the amount of information we can get out. And I wanted to just highlight, next slide, one particular study where we looked at head and neck patient reported outcomes that had been collected over a couple year period of time in our department. This was also led by Dr. Eisbrook. So we analyzed about 33,000 questions, and we looked at a couple different questions within this. Which specific questions on a survey were highly correlated with patients' overall quality of life. We looked at the correlation between questions. So if you're asking, for example, we have a whole questionnaire that's 17 questions about xerostomia or dry mouth. We looked at how highly correlated those answers are. Can you get the same information out of asking a patient one question about their dry mouth? And then we also correlated it with observer or physician reported toxicities. So most of these patients had clinic notes, also with toxicities graded by the clinician or provider that they saw. Next slide, please. And first, just to benchmark whether we can get the same information out of different questionnaires. So on the left, so we benchmarked pain. So the SAQ on the y-axis on the left is a 3-question survey asking about overall quality of life and pain. On the y-axis on the left, the University of Washington is a 30 to 40 questionnaire. We first just asked, can we get the answer about pain similarly from these two different instruments? And it looked like we could. Looking at Pearson correlation coefficients and AUCs, regardless of your pain level 1 through 10, or it's asked 1 through 5 on the University of Washington, we saw similar results between these two surveys. Next slide, please. When we looked at associations of overall quality of life, we saw the highest associations with overall quality of life were recreation, entertainment, activity, and level of fatigue. While employment was at the very bottom of the screen, was least correlated with overall quality of life. And I think the number of people who have changed jobs or quit their job during COVID may be a good gut check that this data was accurate. Next slide, please. We looked at observer physician graded toxicities versus how the patient reported their toxicities. That benchmark of pain is in green on both of these Pearson and AUC force plots, but you can see that with that benchmark of pain, physicians aren't very good at picking up patient reported toxicity. So helped us in the clinic answer the question, yeah, we do need to be collecting patient reported outcomes to really understand what is going on in follow-up. Next talk. And when I mentioned we looked at the number of questions that were correlated with each other. Maybe not surprisingly, we saw that with, for example, dryness, a lot of those questions were highly correlated with each other. And so the practical application in the clinic is an ongoing effort to have kind of first and second echelon PRO questions that are delivered electronically. So for example, if you say in the initial questionnaire, you have a high degree of dry mouth or swallowing difficulty, it will open up to a second echelon of questions that really drill down the specifics of that side effect. Next slide, please. This has also led to, in collaboration with some of the PRO outcomes we've seen in our clinical trials, an ongoing prospective effort to follow our patients from a toxicity standpoint and potentially even a cancer surveillance standpoint with electronically delivered emailed quality of life surveys. So for our good prognosis HPV related cancers, we are prospectively surveying people on a monthly basis with the primary goal of looking at the feasibility of electronic survey administration. And then secondarily, looking at the cost savings, the number of survivorship visits that can be driven potentially by PROs, as well as the sensitivity and specificity of the quality of life surveys we're using for detecting recurrence, and also comparing different surveys for quality of life. Next slide, please. So how that is going so far, just looking at the primary feasibility question, of the 91 patients who have verbally discussed this with their provider in the multidisciplinary head and neck clinic, we've lost a lot of patients to just lack of interest or not being able to be contacted, or not wanting to use email, but 65 of them have signed consent, and of those 54 have been completing the surveys regularly. Next slide, please.
Did you want to take a pause here for a quick question?
We can ask any questions.
I don't see any questions. Here. Who, this is from Manuel Yu. Who or which group does all the analysis that's presented here? How do you get the analysis actually done?
So the analysis, we have a group of biostatisticians that work with us. We carry out analysis ourselves as well. So there's no single answer for what happens. It depends on the project that's being carried out.
I think later on, towards the end, I think I'm going to be interested in getting some sense of the overall magnitude of resources that you've managed to devote to this effort. But we ought to go here to a question from Diane Wilson. Within focus, did your people who declined to participate represent one demographic more than another compared to the overall population?
We are looking at that right now. I'm putting together an ASTRO abstract due next month. So if you email me in 2 or 3 weeks, I will have an answer to that question. Just eyeballing the data, it seems that patients over 70 were less likely to participate in this, which has been shown in other data sets as well.
Okay.
Doug,
Yes.
I have a question. Am I allowed to ask a question?
Yeah, of course.
Okay. So this is kind of a bit of a blue sky question, but I really want to ask you both about the field of radiation oncology. And as I think about the enormous work you've done and how successful you've been, to what extent do you think you might have gotten a kind of boost from a kind of culture of quantification that might exist in your field, especially with its ties to physics, that might not exist in other fields? Maybe you get a sense of this from talking to people from other fields or your interactions with them.
we are a bit of a nerdy group who likes to quantify things.
It's hugely important to what we've been able to do. Yeah.
Yes,
Do you think, go ahead, Doug.
no, go ahead, Chuck.
I was just going to ask if you figured out some way to make this contagious across different fields. Do you think this is something that's going to happen or over time? How do you build a culture of quantification?
I welcome to answer too, but I think you build a culture step by step, and I do think that we've had lots of multidisciplinary engagement from at least within cancer, other interested groups in the Cancer Center, and the buy-in, at least at the physician level, seems to be directly tied to being able to get something back. So if you can see that by collecting a small amount of quantifiable information, you can easily look back and see, for example, who your patients are and where they're coming from, and how they're doing, and how something in the clinic you're doing is affecting them. I think that's a positive feedback cycle that makes me give Chuck more and more quantifiable fields.
Well, in fact, as a sort of a segue directly from that, Mark Kessler says, how can we better help clinicians across our enterprise plant the seeds in straight and parallel rows? Going back to your farming slide.
Yeah, absolutely. And I'm mindful of the time, so I don't know how much time do we have, Chuck F. remaining.
For the session runs until 1:30.
Oh, 1:30, so we're good.
Yeah.
Right.
Oh yeah, yeah.
Oh, I don't.
No, you're good.
Okay. Yeah, so I think that's a fantastic question. I think part of the answer is in Howard Markle's book, The Secret of Life. I don't know if any of you have read it. Howard Markle is an historian from here, and he's looking at the discovery of the structure of DNA. Takes a terrific look at the role that the many players played in that. A fascinating part of that for me has been the role that physicists played in those fundamental discoveries, and how much was driven by it, and also Ann Arbor. And so the importance of conferences held here by Luria in Ann Arbor, gathering together physicists and chemists and biologists, and sorting out what was needed to, who were the connections who were making the advances. It's really fundamental. We joke inside of radiation oncology about our four walls. So we find that physicists are understood inside of radiation oncology, but their ability to act as mortar between stones, where those stones are different domains of knowledge, not really necessarily seen in as many other disciplines. So I think Mark's question and Chuck's question, or Chuck F's question, for how do we get this beyond, is what we're doing now. We come to LHS, and we start to show what we have been able to accomplish working together, that it's not specifically for radiation oncology. These approaches can generalize to other departments. And indeed, we're working with other groups who are making fantastic strides within their domains and leveraging similar approaches. So I think the way in both to reach out is to be engaging with groups like this, and being able to start to cross some boundaries where we haven't normally. So being able to get physics to help groups outside of radiation oncology, because there's, just as with the discovery of the components of DNA, I think there's a lot that's added with that spanning of different knowledge domains.
Okay, we probably want to let you folks get on with your presentation here, and I'm sure we'll have more questions as we go.
Okay, super, thanks. So we'll give you some more examples of how we've started to grow from this, and we've stressed a number of times the importance of starting to reach out. And one of the things we began was the Lambda Consortium, so learning, analytics, multi-sensor, big data aggregation. So we have a number of major institutions from Canada, Dalhousie University with Amanda Casey is she is really a leader in the field. She has been the reason that a lot of these standards have propagated across Canada. So it's very influential. MD Anderson, University of Pennsylvania with Ing Shao leads NRG. So these tie-ins with how this is going to work for clinical trials, University of Alabama and Oregon Health Sciences Center. And so we started looking at DVH curves and metrics. And again, going back to that context slide, that denominator of 73 patients, 5 patients, that's the thing we want to change fundamentally. How do we get to the point where we're expanding this? And so we have a data set from these 5 major centers looking at over 4,600 patients. So we could start, before we get to the outcomes, just looking at normal. What are our differences in practice norms, right? We treat all of these head and neck patients. Do we treat them in the same way? Do we treat them in different ways? Because we have similar expectations for the toxicities and the cure rates. Are we all in about the same position? You'll remember those dose volume histogram curves that Michelle showed. And so these are statistical curves. So the dark pink shows the envelope encompassing 90 or 50%, 70% of all the curves are inside the next layer, and then 90% in the other, and the dashed line being the median value going through all of these. And you can see if I'm looking at the submandibular dose or gland that got the lowest dose, right? That's the one. If you can spare it, spare it. There's dramatically different experience between all 5 of these institutions. Or if I'm looking at larynx affecting swallowing and dysphagia, there's substantial differences there. With this data, we can start to construct histograms of the distributions to see for a particular metric. So here, if I'm just going to look at the average dose in gray, you can see institution A is just systematically pushing this far to the left. And the others have substantial variation in this too. And the reason I mentioned this one is that most models will pick a particular metric, like the mean, to say, here's the correlation with toxicity. And there's substantial difference. But by going through exercises like this, where we have them from multiple institutions, we can start to make a composite distribution. So you can start to then make Monte Carlo studies to say, if I've got a patient who walks through the door, and I don't know which institution they're going to go to, what's the likelihood of what their dose will be? And so this data that we start to pull together starts to open the possibility for other kinds of studies that we can carry out. And as we did this, and we looked at different structures, we looked at the volume of the structures. Here are the standard, if you're just going to pick one metric, which one are you going to use? The median and Q1 and Q3 quantiles, and then what the literature-based constraints are. And so it's interesting when you look at things like parotid and submandibular glands that are corresponding with dry mouth or xerostomia, and you look at the constraints that people recommend, but then you look at what's really the experience overall. On average, patients are getting much higher doses than these regular constraints. And so this is tied to a toxicity. You might wonder, shouldn't we be seeing a lot of toxicities given this reality? We learn, if I look at literature constraints for the esophagus, we start to find that across all these institutions, they're routinely doing much better. So if we're creating these plans, maybe we should just be systematically pushing harder. So not just stop at the literature-based constraints, but actually using the data to drive what you can do to make it better. Oral cavity was an interesting one. So this is a place where there's less similarity between the institutions, but this has already been useful as we start to find outliers. So you look at a particular patient's contour and it's 300 cc's, and you say, this is not going to be like the others. What's happening here? So it's already folding into some quality efforts that we do. We're very interested, as we said, in standardization. We realize that this is, again, a sociological effort. We have to work with groups to be able to pull these standards together. You've all heard of the term herding cats, but what happens when the cats decide to try to organize themselves? Can you make a common data model? And we've had some success. You saw that in what we had done with TG263. The Big Data Subcommittee, which I chair, is again working with these multiple professional societies to develop a standardized ontology. So let's find out what are all the key elements and attributes and value sets we need to, that everybody says, here's the list of what we commonly need, and prioritize that list. And we discovered as we were doing this an interesting juxtaposition of efforts. So contemporaneous, there was an effort going on that's led by MITRE and HL7 in ENCODE and Codex. Some of you may have heard of this. And Astro was leading in participation along with Jim Haven. So you'll see this thread occurring over and over again of the people who were involved in multiple components of it. In being able to design a better electronic communication between the electronic systems we use, so that you can get out treatment summary information in a uniform fashion, right? Something as simple as what did I do? It should be easy to transmit that. It turns out it's technically difficult just because of inconsistencies and variabilities. HL7 FHIR is emerging as a standard for how information is transmitted. And so Astra was leading in developing this, and AAPM joined in. And now we found that there's this tight integration that's emerging from these professional society-led efforts that's also tying into clinical trials groups like NRG. Just to highlight, the Big Data Subcommittee is physics, physicians, multiple institutions, multiple nations, all working together to try to identify what's the common ground, what's the starting point. And we recognize as we do this that what we're giving a list, but it's a process because it will go on. It will need more people involved as we do this. Right now, we put up a website to represent what AAPM Big Data Subcommittee is doing with this operational ontology, which you can find here. It's public access, which is identifying the data elements, the key data elements, the attributes, the relationships between them, the standardized value sets. We're working with the clinicians because, again, it has to be clinician driven, right? Standards shouldn't come from non-clinical people for what clinicians should be doing. And they're setting priorities for what should be aggregated, how these should be done. It works tightly with professional societies, so we have consensus and endorsement. There's a lot of effort right now for including social determinants of health metrics. So you can see this is actively including ethics and quality. We have standardization. One of the products of this is also developing a standardized database schema based on this operational ontology. Just a little more information on ENCODE. If you don't know about it, look for it. It really is important. It's well beyond radiation oncology. This was a use case sponsored by Astro for developing common data elements to support radiation oncology. There are many groups inside of ENCODE having different use cases. So clinical trials groups, medical oncology. Our particular corner is over here, starting with a very small set. So you'll remember ORO is taking a big set of key elements. It's very comprehensive. This is focused more narrowly. That's why that communication between all of them, particularly around the professional society-led efforts, is really productive. And it's a very large group that's participating in Codex with the professional societies, many vendors, government agencies, Canada as well. I'm going to give you an example of how the analytics is coming in for us. So there are too many examples to go through for how we're using this data to expand that denominator. I've pointed to a few times. In fact, there's a recent one in a project led by Dr. Lawrence, as we're trying to understand the natural history of lab markers for liver function, the ALBI score. And we have a data set that involves thousands of patients being able to do that. It's all enabled by constructing learning health systems like this. Instead of going into some of those details, in a minute, we'll focus on one example here, where we wanted to understand for our head and neck patients, Dr. Mierzwa had pointed out, there's this issue with them going to the emergency room. Can we understand why? So we have the data coming in and we have predictions, but we really want to go beyond just models. And we want to develop understanding. So black box model isn't quite enough. We need to be able to develop methods so we can get some details and some actionable thresholds that fit with the way a clinician thinks about it. So we developed an approach where we would look at the set, we carry out statistical profiling, actively engaging the clinicians in the evaluation and the modeling. And then as we do this, iteratively looping back as we discover, oh yes, there's another piece here. You know, if the clinician says, yes, you need to add this, and then we loop back a few times to be able to construct that model. And again, because we have a learning health system, it's not a small denominator. So we have over 1,300 patients. It's a very extensive discussion in our method for how we did this. There were 171 candidate variables that we looked at. We started with carrying out statistical profiling of each of these to find out the strength. So we're not just looking at the black box, we're also looking, if you use classical statistics, how certain would you feel? What would your odds ratio be for that as a predictor? In this case, the number of emergency room encounters before the visit, turning out to have a high specificity. This was a suggestion from Rich Medlin, who again is another person involved in LHS, leading their LHS system in the emergency room. And so you find these people around the university who are already doing parallel efforts and then form those collaborations, as we had done with Frank Warden in medical oncology.
I think it's really, sorry, not to interrupt you.
Please go ahead.
To score the multidisciplinary collaboration and the constant looping of modeling and clinician interface. As Chuck was developing a lot of these models with our statistics team, we're constantly going back to Dr. Midland in the ER, to Dr. Warden and Dr. Swisicki in medical oncology, and to Dr. Schoenwolf and I in radiation oncology with, like, does this make sense? Is this the metric we should be looking at in this realm? Is this highly correlated with something else? And the practical application of the result of this modeling is potentially we're working out the prospective intervention, but an additional nursing call to patients that seem at high risk for going to the ER, or seeing them a second time during the week, instead of having 2 weekly visits. Maybe also an EHR dashboard that identifies patients with certain characteristics as high risk. Sorry, I didn't mean to interrupt.
No, thank you. I mean, this is vital, and it underscores the nature of what we're doing here. It's that, and back to that original slide, you need that combination of domain knowledge, the clinical, the statistical, the machine learning, pulling all of these pieces together. Machine learning algorithms are fundamentally statistical beasts, and they can discover associations that are numerically significant, but a clinician would immediately understand as not actually pointing to what you think it's pointing to. And so that tight integration into this process, we think, is very important. And this step of adding the statistical modeling on top of it to help winnow out the wheat from the chaff in looking at these inputs has proven really valuable to us in this effort. And so as we did this, we started with our candidate set of 171 variables. And again, it's very comprehensive. We're doing radiation oncology. We're looking at labs. We're looking at, let me come back here. We're looking at doses. We're looking at medication uses. We're looking at distance from the hospital. We're looking at a very broad range of inputs to ask, what really makes sense. So we're not determining up front what makes sense. We're letting the data tell us what matters the most. And so from that initial set, then we go through in our process and whittle down to an initial set for looking at all of the machine learning algorithms, and then we prune that data set further and come down to 11 for determining which ones matter most. And instead of stopping just at, I have a model that gives me an AUC of 0.81, the sensitivity of 0.89, we really need to be able to, we use a process that lets us go to ask, well, what are the thresholds and what are the values that make sense? So a physician can figure out, well, how would I fold this into a practice care pattern? So while we're doing radiation oncology and we're tempted to think everything is about the dose, what emerges as most striking here is the number of opioid medication types, or the number of references to opioid prescriptions for the patient during a particular time period. Dose matters, so we have thresholds here for the volume. How big is this volume that we're treating? This insight came from Dr. Warden. What's our mean dose for the superior constrictor? This comes from Dr. Mierzwa. Understanding the symptoms that drive them in. Number of ED visits prior to therapy. This, this element came in from Dr. Medlin. We find out it's not so much predictive for going to the ER as predictive for unlikely to go back to the ER during this course of treatment. There were several labs and also rate of change of labs that have emerged as significant as predictors. Michelle, do you want to comment on any of these as we're here?
I guess, it has helped us with insight in the clinic. Number of opioid medications is, I think, in clinical experience, highly correlated with uncontrolled pain, which is something we've chosen to focus more on in the clinic in PROs and direct physician interaction. Some of the labs pointed to overall measures of health, including some of the liver function tests, but also dehydration and the electrolyte abnormalities and renal panel changes that we saw.
And we also saw that distance from the hospital emerged as relevant. And this doesn't, that may mean that they went to another hospital, right? We don't know from the data set. It may mean you decided it's too far, I'm not going to go. It may be something else. But from the standpoint of evidence-driven hypothesis generation as the pathway into clinical trials, what this is definitely doing for us is telling us where's the signal that it's worth taking a deeper dive to take a look at. Almost done. Another part that we're very proactive about is building community, supporting these consensus solutions. So we have, over the last 5 years, routinely carry out a practical big data workshop here where we're bringing investigators nationally and internationally who work in these areas to make recommendations, publish them, and define common solutions. So in summary, I think the most important thing is think globally while acting locally. We can focus on constructing everyone within their own system. What are the pieces of information you need? How do you need to get them? But being mindful of how this is going to generalize outside your own experience is really important. And that goes to engaging professional societies and building community. And the key component that it's not just about technology, it really does mean fostering a data culture. Thank you.
Well, now we're have time for more questions, and we're going to open the lines up so that you can ask your questions directly. We do have a question here from Liz Downs. Liz, do you want to ask your question directly? If so, you can unmute. Not hearing you, I'll go ahead and ask the question for you. The question was, do you use Data Robot to try out many new machine learning models?
So we carry out the analysis. This analysis with the emergency room was carried out in R. We also do it in Python. There's a lot of tweaking that's needed to actually be able to pull things out so that you can add in the statistical components of this, which is not part of all the models that we found. And so that has been, both of those platforms have been really terrific to work with.
Liz, do you have any follow-ups to that answer? I see your presence now. You're still muted though. Okay, we'll go forward. Lacking other questions at the moment, I have both an observation and a question. What you've described to us here is really a rather spectacular and broad use of the learning health system approach. And I'd be very interested in knowing the answer to two questions. The first one is, do you think that we've already talked about the fact that the community that you practice in has a lot of quantitative activity, and that may have been helpful. But are there other things that you think were particularly important in allowing you to build this community and this set of activity? That's my first question.
I cannot overstate enough that none of this would have happened without Ted, Jim, Reshma, and Lori. If your leadership does not believe in where you're trying to go, and is willing to support you and provide you, they don't have limitless resources. And to your earlier question, we operate very lean, but it still requires willingness to commit resources to be able to do that. And I think that's probably the most fundamental difference for why it's happening here, is the leadership we have in our department. And Michelle, I can't overemphasize
Very much
enough the importance of what Michelle has done. I mean, she's going to be very modest, but she has been a driving force in adopting these approaches and using them and promulgating them to other departments. All of that is fundamental, because what makes it work, the technology is important. What makes it work is the human interactions.
Doug, can I jump in and say that there's a question in the chat from Heather Martin?
Are you giving any of this output back to the physician or care team to help them make better decisions? Oh, yes. If yes, how are you going about doing that, like through clinical decision support, for example? Great question, Heather. So you can see from the example from the emergency room, from what we did in COVID, for defining DVH metrics from the analysis from the PROs. Yes, we are absolutely we're committed to showing that value. Again, we operate very lean. We use the resources that we have to be able to do that, but believe in a future where we've figured out how to do this in a routine fashion that works, and a lot of it can be automated through dashboards to give some guidance, and then start doing deeper dives as you're finding signal. You want to add anything there, Michelle?
I don't think so.
So Robin Ann York said, you've communicated how clinicians are involved in big data. Do you have capacity for CDS with patient report that's automatic or manual, given to provider team as additional data applications?
Sorry for my ignorance. What is CDS?
Let me jump in and say that CDS, I believe, refers to clinical decision support.
We are, oh, okay, great question. So we are approaching this by by demonstrating value to then try to get resources to expand using this for clinical decision support. But I think you would argue that Dr. Mierzwa is already doing that as part of her practice. Do you want to take this, Michelle?
Yeah, I guess, if you're looking for one of the ways, I guess, in the big picture in the future that we were planning to potentially have real-time clinical decision support potentially is my chart alerts for patients that are at high risk for the ER, or patients that are high risk for toxicity. I guess in a current version, we are able to see patient-reported outcomes in real time. There's a dot phrase that also helps you pull them into your note after patients fill them out as part of e-check-in. We're working on it.
It's a journey.
And I guess the other part of this, maybe the number of Tableau dashboards that allow us to look at aggregate data in a variety of domains, albeit in another system currently.
Are there other hands raised?
No.
Okay. So, Chuck, I don't know if you have any closing comments you'd like to make. We got two Chucks here.
Oh, that's right.
Chuck Mayo, do you have closing comments, and then Chuck Friedman?
Please feel free to reach out to us if this is an endeavor you're interested in taking up and something you're trying to exercise and you're looking for community. We believe in this direction. It's not just RADONC. This should be spanning departments, and we're very enthusiastic about helping this to happen.
Well, and I should say that this is exactly what the Collaboratory is about, to a very large extent, bringing these experiences to a broader community so that the work can be shared and we can understand what the possibilities are. And it's been an extraordinarily useful presentation. Michelle, any comments from you here as we close?
I do not have anything to add right now.
Okay. Chuck Friedman.
This is awesome. This is just completely and utterly awesome. I just want to thank both of you, Chuck M. and Michelle, for this presentation, which was very clear and was such a synergistic blend of clinical and, call it, methodological concepts and applications. So thank you so much for this, and we will, through the Collaboratory, be finding opportunities to take you up on your offer to help others who are seeking to do the kinds of things you were doing, and there were many, to take advantage of your experience. So thank you again, and if we do not have any further questions, we should call this very, very informative session to a close.
Yes, and please fill out the post-event survey. You'll see the link available as you exit the webinar. Thank you very much for the presentation, and thanks to all of you who have taken the time to join us today. Bye now.